We're now looking at Chapter 1, Lesson 3. The title is Properties, and you can see that the Common Core standard has changed to 5.08.1. Perform operations with multi-digit whole numbers with decimals to hundredths. Before we start the actual homework assignment, I'm going to review some of the things that we'll be needing to know, starting with our properties, like the title suggests. Your Go Math book is going to separate the addition and multiplication in two different paragraphs. However, I'm going to group certain properties together. What I mean by that is we're going to start with the commutative property. And there are going to be two types. There's going to be one commutative property of addition. And then there's going to be a commutative property of multiplication. What the commutative property states is that you can switch two numbers when you're adding or two numbers when you're multiplying and still obtain the same result. So let's say that you have the numbers 12 plus 19 plus 18. Now, I'm looking at the ones place value and I see there's a 2 and an 8. And anytime I can make it 10, I'm pretty happy because I know that 8 plus 2 make 10. And so now all I have to do is add the 10's values together. And so what I'd want to do, instead of doing the 12 plus the 19 where I'd have to regroup because 2 plus 9 is 11, I'd want to add the 12 plus the 18 first. And so if I were to rearrange that, 12 plus 18 plus 19, these are called add-ins. If I were to switch the add-ins around, the 18 and the 19, so that I could add the 12 and the 18 first, I'll still get the same answer or the same sum. The reason being is, you could have 12 dogs, 19 cats, and 18 hamsters, and you want to find the total amount of animals, but you could switch the animals. It doesn't matter if I count the cats or the dogs or the hamsters first or whatever I already forgot what animals I used as an example. But there's not a specific way that you have to count them. You'll still get the same sum. When you're just switching two numbers, like I did here, you could see that the 19 and 18 switched positions. However, everything else stayed the same. The sum will stay the same. The answer will still be the same. And the reason why you'd want to do that is just for quicker ways to add, especially if you see in the back ones, something that adds up to 10. Likewise, you could do that with multiplication. For instance, I could do 5 times 8 times 2. Actually, let's make it 5 times 7. Instead of doing 5 times 7 times 2, I can look for another thing that makes 10. 5 times 2 make 10. And what I love about the 10's place value, as we learned from the previous chapter, all you have to do is move one place value over. So instead of doing 5 times 7 first, and then thinking if I'd have to regroup because 5 times 7 is 35, and 35 times 2, I'd have to do 5 times 2, and this and that. I want to do the 5 times 2 first. 5 times 2 times 7. You could see here, again, we switched. This time we switched the 7 and the 2. Again, we switched the numbers, but it doesn't change the final answer. Now here they were called add-ins. When you're multiplying, these numbers are called factors. So we could change the two factors and yet we'll still get the same answer. And the answer to multiplication problem is the product. So whether we do 5 times 7 times 2 or we switch it around, 5 times 2 times 7, we'll end up with the same answer. And that's what the commutative property is all about. Switching two numbers for addition, for commutative property of addition, or for multiplication, for commutative property of multiplication. You might be asking, Ms. Tolentino, how come there's no commutative property of subtraction? Or, well, let's think about it. Let's go on the side for a second and do that. Let's say we do 9 minus 3. That equals 6. If we switch those two numbers around and we do 3 minus 9, it no longer equals 6, equals negative 6, because now you owe some money. So that doesn't work for subtraction. So when we're talking about switching two numbers around, it works for addition and it works for multiplication. It also doesn't work for division, and we could use those numbers again. If we do 9 divided by 3, it equals 3. But if we were to switch the 3 and the 9 and do 3 divided by 9, it would equal 1/3. And so commutative property, the switching of numbers, will only work for addition and multiplication statements. And keep in mind that they're either all addition or all multiplications. You don't switch these two around. That's the commutative property. You're switching either two add-ins or two factors, and you're still getting the same sum or the same product. In other words, you're switching two numbers with adding or multiplying, and you still get the same answer. Let's now see how that's slightly different, not even that much different, to the associative property. The associative property also has of multiplication and of addition and of multiplication. So you could have two different answers. You can have an associative property of addition, and that's when we're adding, or an associative property of multiplication. The associative property is very similar to the commutative property. The only difference is that we're going to change groups at this point. We're going to change the parentheses. So let's say that there's parentheses around the numbers 6. Ooh, sorry, I apologize. Let me start again. There's 6 plus 8 plus 14. Now remember what I said about looking for numbers that add up to 10 in the ones value? Here's a 6 and a 4. I want to add these two up first, because if so, then I'll get a value of 10, and I could just add the plus 8 at the end. So instead of doing 14 plus 8, where I have to regroup and then add the 6, I could simply do 6 plus 14 first, plus 8. So instead of doing 8 plus 14 is 14, 15, 16, 17, 18, 19, 20, 21, 22, plus 6, 28. I could do this instead. I could do 6 plus 14, I know is 20, plus 8 is 28. So these two, they're saying, are equivalent. You can change, you could see what I did here. I grouped the 6 and the 14 together so that I can add up to 20 quickly, and then I add the 8 at the end. If you're changing now the grouping, it's now called associative property. You can see that the commutative property and the associative are very similar. The only thing is you're now changing the groups. Because remember, when we're doing, please excuse my dear Aunt Sally, when we're doing PEMDAS, we would have to do the parentheses first. But you could change the parentheses around so long as they're all addition. Let's look at an example for multiplication. Sorry for all the shaking. Let's say that the next one is 11 times 3 times 6. Here we could do 11 times 3 first. This is the example from the book. So we could do 11 times 3 is 33, and then times it by 6. So instead of doing 3 times 6 is 18, and then multiplying by 11, we could do 11 times 3 is 33, then multiply by the 6. So, commutative property of addition and of multiplication is similar to the associative property. The only difference between the two is the fact that one is regrouping, while the other one is just switching the numbers. All right, we're halfway there. We have to learn about the identity and then the distributive property before heading on to our homework. So if you need to, you could pause and review the two properties we've learned so far, but I'm going to start with a new color. We're now going to be looking at the identity property. And again, there's one for addition and one for multiplication. What I love about the word identity property is the name of it. The identity of someone is the person's name. So my identity can be thought of as Katrina Tolentino. The identity of a number could be thought of as its name. So let's take the number 3. The identity property of addition states if we were to add a number to 3, what would we add so that the number it still keeps the same identity. So the number is still 3. So think about it. 3 plus what number will allow it to still keep its same identity, its same name? When will it still be 3? Let's try adding some numbers. If I do 3 plus 1, it now becomes 4. It changes its identity. If I do 3 plus 2, it's now 5. It's changing its identity. So as many of us said during class, the answer is 0. So the identity property of addition is if you add 0 to a number, it retains the same identity, it keeps the same name. Think about multiplication. Now, instead of adding, since it's multiplication, it's asking if you were to multiply a number, what would you multiply so it keeps its same identity? So let's say it's 5 and you want to still keep it 5. Let's add the 0 that we had from addition. If you do 5 times 0, the answer is 0. So here, what number can we multiply by to keep its same identity? Well, if it's not 0, let's try 1. 5 times 1 is 5. When you multiply a number by 1, the number stays the same in value. It's still the same name. This one's going to be very important when we start doing fractions, and then you'll see why. Because there's other ways to say 1. But I don't want to get too ahead of myself, but that is a little exciting to know. The identity property of addition is you can add 0 to a number and it retains the same identity. 3 plus 0 equals 3. 5 plus 0 equals 5. 100 plus 0 equals 100. 1,037,000 plus 0 equals 1,037,000. Miss Tolentino plus 0 equals Miss Tolentino. In multiplication, you could multiply a number by 1 and it retains its same identity. 5 times 1 equals 5. 6 times 1 equals 6. 7,032,000 times 1 is 7,032,000. Miss Tolentino times 1 is Miss Tolentino. Last but not least is one of the hardest ones. However, we are going to have a couple lessons dedicated to just the distributive property. So if you don't get it right away, if you don't get it, the distributive property in this complete video in its entirety, don't fret too much. I believe this coming week, when we hit lessons 5 through 8, it will touch a lot on it. So, last one that we're going to be learning for this lesson is the distributive property. And this is going to be one where there's not one of addition and one for multiplication. It's just called the distributive property. And what we're going to do with the distributive property is we're going to break down numbers to make it easier to multiply. So let's say we have the number 5 times 16. Instead of doing the way that you've learned, where you go 16 times 5, you do 5 times 6 is 30, 5 times 1 is 5 plus 3 is 80. The answer is 80. They don't want you to do it that way. What they want you to do is they want you to start thinking of the number in a way where you could decompose it. So let's look at the number 16. What's another way to get 16 if we're to separate it by the 10s and the 1s? 16 is the same as 10 plus 6. So you can see here, these are the same equations. 5 times 16 is 5 times 16. 16 is 10 plus 6. These two are the same equation. 5 times 16 is the same as 5 times 16, or 10 plus 6. The second step in the distributive property is now you take your 5 and you're going to multiply it by the two numbers that created that 16. So you're going to do 5 times the first part of 16, which is 10. 5 times 10. Then you're also going to do 5 times the second part of 16, 16. 5 times 16. Oh, I mean 6. I'm sorry, not 16. I was getting ahead of myself. 5 times 6. So you can see here, 10 and 6 make that original 16, and you're multiplying 5 by it. 5 times 16, 10 and 6. Since 16 itself, 10 plus 6 makes 16, we're going to put an addition sign in between them. So the distributive property. First, you think of your two numbers. You break your the two-digit one into its 10s and 1s, and then now you multiply. 5 times the first part, 10, and 5 times the second part, 6, and 10 plus 6 makes 16, so there's an addition in between. Now, 5 times 10 is 50, and 5 times 6 is 30. 50 plus 30 make 80. And so you see that you still get the same answer here, but it's through a different process. This one is one where you regroup and do other things, whereas this one you're thinking of in a different way. And so these two will both derive at the same answer, but they don't want you to do this for this lesson. They want you to try using the distributive property. So let's go look at our lesson now. And you can see that we're using some simple numbers. And these are problems that you're like, Miss Tontine, I could have done this last year. I could have done this in 3rd grade. Yes, that's true, but read the directions. Because once you read the directions and what they actually want you to do, it's a little bit more complicated. They want you to use properties to find the sum or product. The sum is the answer to an addition problem, and the product is the answer to the multiplication problem. So we're going to start with number 2 since they already did number 1. Plus number 1 is almost like the distributive property, except we're subtracting instead of adding. So I'm just going to skip number 1 for a sec because, like I said, next week when we hit lessons 5 through 8, it's definitely going to go over that in more depth. But let's look at this. 93 plus 68 plus 7. They don't want you just to use PEMDAS and do 68 plus 7 and then add it to 93. And they don't want you just to go 68 plus 7, 15, 7 plus 93. And if I see that on your homework, because that's not what they want you to do, you will be getting a check minus, which means it will be a D minus. They want you to use properties. And so I want you to start thinking about, all right, should we use the commutative, associative, identity, or distributive property? Well, the identity property has to do with retaining the same number and adding by 0 or multiplying by 1. So we're not going to use the identity property. The distributive property helps us to multiply in a better, not a better, but a different way. We're not really going to be using the distributive property. So that leaves us with commutative and associative. Commutative means we're just going to switch 2 numbers. Associative means we're going to move groups around. Here, a faster way to add would be, we want to add that 3 and that 7 together. So we want to do the 93 plus 7 first. And then add the 68. So we're going to do 93 plus 7 first in parentheses, then add by 68. Because we're regrouping them, and we're using parentheses, and we're switching the groups around, that's associative property. We weren't simply just switching 2 numbers around, we switched the groups. Before we said we'll do 68 plus 7, now we're saying, nope, we're going to regroup it. We're going to do 93 plus 7. So your first part of the answer is you're going to use the associative property. And this is the associative property of addition, because we're adding. Now the reason why we want to use the associative property, because instead of doing 68 plus 7 and regrouping plus the 93 and we're regrouping constantly, we could just say, hey, 3 plus 7 is 10, 90 plus 10 is 100, 93 plus 7 is 100, then we add the 68, 100 plus 68 is 168, all done. So look at how here we didn't have to really regroup. If we added them where we did the ones that could add to 10 first and then add the final one, it makes it a lot easier. All right, let's try the next one. Let's see which property we're going to use. We have 5 times 23 times 2. Again, we don't really need the identity property because we're not adding by 0 or multiplying by 1. We're not retaining the same number. 5 times 23 times 2, we're not going to use the distributive property for this one because this is when you're multiplying only 2 numbers and you're breaking it down, whereas here we're multiplying 3 numbers. So we're not going to use the distributive property. That again leaves us with commutative or associative. Keep in mind, commutative and associative are very similar. The only difference is one is just switching the numbers and the other switching groups. And so here, I want to do 5 times 2 first. So I'm going to have the 5 times 2 go first. Then I'm going to multiply by the times 23. Here we didn't switch any groupings. It didn't have parentheses that said, hey, you have to do this first. And so it's not the associative property, we're doing the commutative property. So the first part of this is we're just switching the numbers. So we have the commutative property of, last time it was addition because we're adding. Here it's multiplication because we're multiplying. Now, when you do 5 times 2, 5 times 2 is 10 times 23. 23 times 10 is 23 plus 1 more place value. 23 longs ends up becoming 230. So your final answer is 230. You add an extra 0 when you're multiplying. We'll go over that in the next lesson, 1.4 actually. So we have 230. Imagine if we were to do it the other way. If we were to have done the way that I don't want you to do, which is, all right, just multiply them in order. 23 times 5 is 15. 5 times 2 is 10, plus 1 is 11. Times it by 2. 5 times 2 is 10. 2 times 1 is 2. Oops, I forgot to regroup. 5 times 2 is 10. Regroup the 1. 2 times 1 is 2, plus 1 is 3. 2 times 1 is 2. So again, you get the same answer, 230. But look at how you couldn't have done that in your head. The reason why they want you to use associative, commutative properties and other properties is so that you could do a lot of this as mental math. You could say 93 plus 7 is 100, plus 68, 168, bam. 5 times 2 is 10, times 23 is 230. They want you to start doing this because it's mental math. Instead of having to regroup all the time and think where these numbers come from, they want you to consider other ways of coming up with the answer instead of just, you know, playing with the numbers so that you could do it more in your head, more as mental math. We're going to do one last one because it will be a new property. And what I love so far is we had different properties. And here you can see that you're just multiplying two numbers. And so for this one, we're going to use the distributive property and we're going to break down one of the numbers. So here, we're not going to have to switch any of the numbers like we would for commutative and associative. There's no 3 numbers, so it's definitely not commutative and associative. And it's not identity because it's not like we're retaining the same number. So we're going to do the distributive property for this next one. Mostly because we're only working with 2 numbers and we're learning how to multiply them in a different way. So what 2 numbers for 51? We could break it down to 50 and 1. 8 times 51. Look at how 50 plus 1 make 51. So 8 times 51, or 8 times 50 plus 1 is the same thing. Now you do the next step. 8 times the 50, 8 times the 1. Because keep in mind you said 8 times 51. 8 times 50, 8 times 1. We're going to add those together. 8 times 50, 5 times 8 is 40, plus 1 extra 0. 8 times 1 is 8. 408. You're going to do the same thing for number 6. You'll also use the distributive property, but instead of it being 50 plus 1, you'll do 100 plus 7. I hope that this video helped you understand the importance of why we're doing this. The main importance is so that you could do more mental math. They don't want you just multiplying it out or adding them up. They want you to start thinking about the numbers. You know, what goes together? What can make it more efficient and effective? Same with this one. Here there'll be blanks that you have to fill in, and they're going to ask you what property you use to fill those numbers in. So let's just do one of them, and you could do the rest on your own. You have the numbers 3, 10, 8, blank, 10, and 8, and you're multiplying them all. So you can see here you have the 10 and the 8. You have the 10 and the 8. What number are you missing? You're missing the 3. So over here you're going to put 3. Because here 3 times 10 times 8 should be the same as 3 times 10 times 8. Now what property did they use? At first they want to multiply the 3 times the 10. Then they switched it to the 10 times the 8. What's it called when you're switching the groups? Instead of doing 3 times 10 first, you want to do 10 times 8 first. Look at your cheat sheet. think to yourself, is that called the commutative, associative, identity, or distributive? And that will be the second part of your answer. And then you're going to keep doing that for the rest of the problems until you hit the problem solving. I'm going to take a deep breath. If I went a little too fast, feel free to pause at any point and rewind it, not just in this video, but in all videos. Let's go ahead and start reading number 11. You could read it to yourself as I read it aloud. The Metro Theater has 20 rows of seats with 18 seats in each row. So a row goes this way. There's 20 rows of seats. So there's row 1, row 2, row 3, row 4, row 5, row 6, all the way up to 20. And in each row there's 18 seats. So there's 18, 18, 18, 18, 18, 18 seats, 18 seats, 18 seats, 20 times, because there's 20 rows. Tickets cost $5. So $5 for the first seat, $5 for the next, $5, $5, $5, $5 for those 18, then the next 18, then the next 18, then the next 18. The theater's income in dollars, if all seats are sold, is 20 times 18 times 5. Use properties to find the total income. So what they're saying is they already gave you the equation. They said this is the equation. So the cool thing about this one is you don't even have to come up with the equation. They said the equation is 20 times 18 times 5. Multiply the rows by the amount of seats in each row by the amount of each ticket cost. But they said use properties to help find the total income. So here, I don't want you to do 20 times 18 first. What two numbers do you want to multiply first? Because you're going to be using the associative property here. And it already says use properties to tell you. What two numbers? Do you think you should multiply the 20 times the 5 first or the 18 times the 5 first? If you do 18 times 5, you're going to have to regroup. Do you know 20 times 5? Is that one of your favorite numbers? And I hope the answer is yes. Because 20 times 5, you should know as 100. 20, 40, 60, 80, 100. 20 times 5 is 100. So do 20 times 5 first and then multiply by the 18. That being said, here's another one. The number of students in the 4 6th grade classes at Northside School are 26, 19, 34, and 21. Use properties to find the total number of students in the 4 classes. So before, unlike number 11, this one they didn't give you an equation, okay? So I'm going to help you set up the equation, and then from there you're going to have to think of which property and what the answer will be on your own. Now there are 4 6th grade classes, so I'm going to draw some boxes to represent each class. Here's class 1, here's class 2, here's class 3, here's class 4. Because there are 4 classes, I only put 4 boxes. There are 4 6th grade classes, the 1st, 2nd, 3rd, and 4th class. Now inside each class, there's a certain amount of students. Inside the first class, there's 26 students. Inside the next class, there's 19 students. Inside the next class, there are 34 students. And inside the last class, there's 21 students. What we want to do is find out how many students are all together. So this, and this, and this, and this. So how many all together? What we would do with these 4 numbers to find out the total cost, X is the total, not the total cost, the total students in all 4 classes, is we would add. So if we were to add the numbers 26, 19, 34, and 21, I want you to think which numbers you'd group and why. Personally, I'm going to look at the ending numbers and would think which ones equal 10 easily. Here's a 6 and a 4. I want to group these 2 together. Here's a 9 and a 1. I want to add these 2 together first. So think about which properties you're going to be using and why. What property is that called and why? All right, well, I hope that this helped you. Let me know if you have any questions, and good luck.